Hi everyone. Welcome to the ILTA Physics online lecture. Today we're going to talk about two of the most fundamental concepts in physics, the system and the environment. In terms of physics, this is an important concept that basically divides the entire universe into two parts. In physics, a system is basically whatever specific object or group of objects we decide to focus on. Think of it like drawing an imaginary boundary around something to see how it behaves. Everything else that's outside of that boundary is what we call the environment or the surroundings. The key point here is that in some cases, the environment can influence our system. Let's look at the image on the right and think about a situation where two friends are pushing another friend's toy car. In this motion, we are interested in the relationship between the forces F1 and F2 applied by the two friends and the resulting motion of the car, which is its acceleration A. In this scenario, our system would be the area that includes both the friends and the toy car. This imaginary line we draw in red is called a boundary. Then everything else outside of the system is the environment. In our example, the ground or even the earth itself would be considered part of the environment. What's important here is that we can see several forces shown in the diagram, like the weight W, the normal force N, and the friction F, are all influencing our system. Depending on how you define your system, the way you solve a problem can change completely. So, always start by asking yourself, what area am I interested in right now? What exactly is in my system? Using this logic, let's define the system and the environment more formally. I'll wrap up today's lecture by briefly summarizing the different types of systems we deal with and their characteristics. Up until now, we've been analyzing the motion of a single object in terms of position, velocity, and acceleration. However, if two or more objects are moving while interacting each other, we need to introduce the concepts of a system and an environment to make the analysis easier. Let me explain this with an example. Look at the image on the bottom right where two balls are moving toward each other and colliding. In this motion, our interest lies in things like the position and velocity of these two balls. In this case, we can define the imaginary area that includes both balls as our system. The dotted line you see in the drawing represents that imaginary boundary of the system. Once the system is defined, everything outside of it becomes the environment. The reason we separate the system from the environment is so we can analyze the forces or energy happening inside and outside separately. First, the forces acting within the system are called internal forces. As you can see in the collision example, these are the action-reaction pairs. The force of each ball pushing on the other is an internal force within the system, and these internal forces cannot change the total momentum of the system. This means the law of conservation of momentum holds true. On the other hand, we have forces acting from the outside. Although not shown in this specific diagram, you could think of friction as the balls roll on the ground, the weight due to gravity pulling the balls down, or the normal force of the floor pushing up on the balls. The important thing here is that, unlike internal forces, forces acting on the system from the environment can change the total momentum of the system. Therefore, depending on how we define the system, in other words, how much of an area we include in our analysis, the way we interpret the object's motion can change completely. Now, let's look at the different types of systems on the next page. The concept of a system in physics can be categorized into three main types based on their characteristics. First, let's quickly recap the system and environment we just talked about. You can think of a system simply as a collection of objects that we are interested in analyzing. And everything else except for the system is what we call the environment. The key is that forces acting from the environment onto the system can affect that system. The imaginary line that separates the system and the environment is called the boundary. By defining this boundary, we can distinguish between internal forces acting only within the system and external forces acting on the system from the outside. These systems can be divided into open systems, closed systems, and isolated systems. To be more scientifically accurate, this distinction is usually explained in terms of energy and matter, but for now, we'll stick to explaining it simply using forces and objects. An open system is one where force or energy, and even object or matter can move freely between the system and the environment. On the other hand, in a closed system, energy can move back and forth, but actual matter cannot leave or enter. Finally, an isolated system refers to a completely disconnected system where neither force, energy, nor matter can move between the system and the environment. From the perspective of object dynamics, we mainly deal with isolated systems. In an isolated system, since no outside force, energy, or matter can have an influence, the net external force becomes zero. Therefore, according to the law of conservation of momentum, the total momentum of the system remains constant regardless of what interactions happen inside. It's easy to understand these classifications if you think of a pot of boiling water. Let's say the kettle and the water inside are the system we're interested in. First, if the kettle has no lid, heat, energy, and particles like steam can move freely between the system and the environment, so it's an open system. However, if the lid is tightly closed, heat energy can still be transferred to the outside, but the steam particles cannot leave. This is a closed system. If we imagine the entire boiling pot is inside a completely sealed, insulated space, and we define that entire space as our system, it becomes an isolated system. I'll explain the distinction between systems and environments in more detail later when we study energy. You all did a great job today. I'll see you in the next lesson.